Okay, beautiful people. Remember, I don't just give the little corny data ahead of time where I'm just bored and I just load it up. And now I have a data stacking I'm doing for you to get you to where I need you to go. It turns out I did post this video I thought I still need to post. I saw it in there already where I talked about the shape looks like this. Ooh, let's go ahead and back that up. It looks like this. And I think it looks like that is what I was showing. And I showed a little car there. Maybe I just use the community tab and I'll put it over there. And here's your loading here. And this is what right here is where you get the little shear break, they call it. I say they call it because I think it's really a tension break and not a shear break. I think the tension is created in there so great that you get this. I'm biasly so. I am thinking shear on the lines of only scissors crossing each other, a punching into something. It shears around the outside walls of it, and that gets you your shearing action. That's the punch that you call it, but in reality, shear took place also. And then like a bolt holding steel together. I saw this one instructor video, and he stated, because I try to debunk myself, and takes me forever to try that, and finally I give up. Well, one guy was like, no matter what, you get deflection is always the cause, and that's my thinking also, but not fully, because you can get shear without deflection. For example, the steel just being overloaded, no deflection in the steel, but the bolts are the weakness of the system. So you get no deflection, but the bolts are the failure. And that would be the bolts over here, let's say. So you can get failure without deflection, although I didn't troll him and say anything to him. I figure he'll come around to that one day. He's just a professor, and maybe, and he's got the same crazy mind I have. Not quite, but it's close. Oh, what do we have here? X22. What is this? Wait a minute. Oh, I see something here. Hold on. Oh, look at that. Oh, look at that. Huh. Let's put the other piece to it. Let's put the piece that we're missing. I'll let you run from here. It's going to be a short video, I hope. Ooh, hold on. Did it again. That's the piece that goes there. Oh, I can't move it. So that piece goes like that. It's over there. Like that. And let's just back that up. Let me just get it out of the way for your visual confusion. Don't want that. And let's do that. So it goes over there. That's the bottom of it. Okay. So let's go ahead and remove those. Let's remove the red ones. And let's put back this. So there's our load that gets that shear action there. There's a column there. Okay. So it's already been, they demoed, so they took away some things here. I'm showing you that this giant H-beam, but it's more than an H-beam because it goes out so it looks like we see it as something like this, but in reality it's got here and here, and it comes over like that. The column's out on the deck here. This is inside the building. So this is the bump out, the kitchen bump out, which went from 4 feet to 5 feet. So that's an upgrade span-wise, but that's just something that needs to be resolved. It's not crying yet. Okay, so we got this H-beam, right? So let's just look at it like this. There it is there. As you look at the plans, you're looking down on it. And you've got a column here that's set off now. It's no longer on top of there in the real world. It's out here punched into the ground. And then we got our column locations, right? Column locations. Let's see, that's inside. So this one's inside. I'm taking some liberty there. And this one's inside. So they both, this one and this one, are inside. So this shifted over. So we have this again. So I'll put the arrow back there so you can understand that's the loading on this. That we look at the X22 and you don't see cracks on it underneath here. Nor do you see cracks anywhere, but you see what is known as a shear failure. Oh, so now what can you do? You can now go to this image Come on, go back some. Trying to go back. Okay. You can now go to this image and zoom in. And when you zoom in, you now start seeing the stirrups. They look like this. And back down again. Well, not quite. Not here. They don't stop there. Hold on. So the stirrups go here. And they go up. Above that. Above this plane right here. See the plane of it? They go above that. In fact, you're looking at the stirrup locations. So if you look at this, you can then reverse engineer this beam. You see the stirrups. You can see how much they put up top there. And now to cut to the chase, you just don't even have to know if it's adequate enough. You simply look at the right here. You look into the meat of this thing, right? Look into the body of it and see if you see any cracks, any fractures, any fractures like that anywhere. And I think you'll not find them. But you do see this one, which means the loads from here, and it would be a load that's so this is the, let's put this as the column, and this is the H on top of it right here. Let's do a little detail shot out like that. And this is the column right here. Well, how do we get this right here outside that column that's over there? It literally has to shift over. Well, we know that. It shifts over with the failure. But if you look at the steel, and this steel, you will see that steel there. It's already, by now, they've already, it's contaminated because, great. All right, so I guess I'm going to make another video for you. But it was content. Let's see if I can do this for you. So you're going to look at the steel here, and you're looking for cracks in here, and you won't find them, or will you? And this is your load, and now you can a lateral load to look at it. I want you to look at the back side of the H to investigate the back side of that H beam, back here where it connects to the other one, and see if you see a break there. That would tell you that this side took more of a torque before it went down, or it'll tell you how it progressed to failure. We also know it shifted down and forward because we have that column here, or did the column just simply slide off and punch into the ground? But we know that, the building did this shift and punch into the ground. Well, I'll give you a little teaser. The teaser is this. Here's the H, right? Let's do the H like this. And we see the column punched in the ground. That column was, come on, give me a different color. That column was here. So did it slide off? Did it break, slide off, and drive down? Well, if it did that, the issue I have is that you still need something to cause the shear fractures off the tails of these, off the ends. And if you start removing the load, you start removing the ability to cause this to fracture all the way here, all the way everywhere. It did not. So it fractured while it was still on top of the columns. That's why you're missing the tails on all these. So the load, when this went to failure, all of this sheared. These sheared at that level. Remember, it looks like a ground up failure. So I said I'd get this into the building, so I'm crossing this into the building now, and I'm going to jump around while we're in the building. So I'm going to give you this now, and we're going to stack from here on this one alone, this H-beam alone. We're really going to work it over, and it's going to tell how it came to stressed to where it came to failure. Remember here, let me change the color. Okay, so remember here, and here, all present as being equally loaded during failure. How would you know that? You're going to look inside the seams here, inside the connections here, and you're going to see if you can see separation. And you will not, because this beam, changing colors, the beam has, let's try blue. Try blue. So this one has steel this way. Wait a minute. Has steel this way and steel this way. All tying this together. So this is where you're going to see, you're looking here, 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 here to see if you can see the steel separated. I believe the floor was still intact when this went down. And then this little lady here slipped off. That little lady is not showing the rebar, is it? Very clearly. Watch my words there. Very clearly it's not showing the engagement from this beam with rebar that's bent over. All right, so watch my words. And what else do I want to show you? So that's our loading. So that's our loading that we see reserved. The loading is, so you're going to look for the fractures in this. Now you understand the end fracture, changing colors. Okay, so this is the end fractures. You understand now that they're what is known as shear fractures. And I call them, and it just basically was supported on the ends. And did it equally, I'm asking you, did it equally, so you can go look at the images, did it equally get pressure here, all through here, and create failure here, 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 and here, punching this section right here, punching the middle H-beam through and down around all of these, the four columns? Did it equally get that? Keep in mind, there's a deck out here. That little nodule right here, that's the story I'm going to tie this all in. It's going to tell you how it all failed also, including that little nodule that's here. It's got a heck of a story to tell, and still and remember the dog cam, I believe that deck was in place then in the dog cam. The dog ball cam, I call it. You know, you shoot between dogs' legs. That was not RT, but whatever. One of those foreign Soviet type. I don't know. Was it RT? All right. So there's your little HE beam. There are your major points that I want you to think about. That guy sitting out on the deck is got a story to tell about its failure, and what you're looking at in real world is the failure of shear fractures referencing. So that's that fracture, why you see it like that. Shear fracturing, and your tails are gone. Now they might have still been slightly connected on the deck when the demo crew just tore them away, because they removed the deck. And we're looking at the shear links. That deck acted as composite. So these are the shear links, the small ones, and the top one is, I'm sorry, I got to think profile, which way in profile I'm helping you look at. So I got it sort of double dipping here, and we're looking at it flat, and I turned the rebar sideways. So there are your shear links right there. You're looking at them protrude above the deck, and we should find, so I got red, so let's try green. Nope, let's try green. We should find steel running across the top here. Not here, but across the top. And I'm just showing you how it would stick up, like that. And below this is the concrete. And then some more steel down here. And then like that. So what we look at above, there's that steel right here. And there's what you see exposed. I believe it was concrete on top, engaged there, as we saw the ball cam. And doggy ball cam, and that. And I use those names like that because I learned it from a professor I had a long time ago. He was an older guy. Loved him to death. He was quite the character. And he said, you know how I can help you remember this? Is if I curse and if I threaten to stab you in your eye and everything. Oh my gosh, when he first did that, you can bet he had everybody's attention. You know, he's dead now, but he was an older guy. And he said that, you know, he's advanced for his time saying that. You'll remember it now. And he's right. That's one of Pavlov's experiments, basically. Hey, if I tie it in with like ball cam, you'll remember it. You won't forget it. And I'm not threatening to poke you in the eye or stab you in your... Or rather, one of his things he said was, I can stick this in... He tried his voice like this. I can stick this in your spinal cord paralyze you. Hey, Bruce. Bruce served me. I'm just doing my voice, Bruce. Chill out. So I could paralyze you, beat you up. You couldn't do anything about it. And then pull a needle out, and then you'd feel all the pain. You can bet he said that to everybody. Everybody, oh, we stayed awake. All right, take care.